Jai Hind, dear students. I am here toward you for the very important topic of Unit 3 of the computer network. So basically, myself, Dr. Santosh Kumar Upadhyay, Associate Professor in CSC Department, AKGC Ghaziabad. Today we will discuss a very important topic of computer network that belong to the Unit 3, basically IPv4 classful addressing, and let me see in the next lecture the subnetting part also. So IPv4 means this is the topic that is related to the network layer basically, okay, network layer, because we know that at the network layer there is a functionality that ensure source to destination delivery of the message, okay. So for source to destination there should be some logical address that may be some address that identify the source and that identify the destination, okay. So basically there is a two approach here, two option here. First is the IPv4 and other is the IPv6, IPv4 and IPv6, okay. For what purpose? These two protocol work at network layer, okay. So IPv4 means Internet Protocol version 4 and this is the Internet Protocol version 6. So IPv4 basically uses 32-bit address, and IPv6 128-bit address, okay. So I am here to discuss this IPv4 32-bit address. What is the 32-bit address and what is the classful addressing basically, okay, we will discuss here. So as we know that everywhere when we have to ensure, we have to design the address of a particular maybe place in real world, maybe place, okay, maybe some office, then what we have to do? We have to certainly divide that address in some hierarchy, like what is the plot number, before that what is the flat number, plot number, what is the street number, what is the locality, region, then what is the district, then state, then country, okay. See here, these are the hierarchies, okay, hierarchy, because without hierarchy the information or the message could not be successfully delivered at a particular address, okay. So similarly here in the IPv4 also there is a two level of hierarchy. Here there is a two level of hierarchy. One is the network level, okay, other is host level. Network level means network ID. This is also known as the network ID, and this is the host ID, network ID and host ID. So in IPv4, as we know that there is a 32-bit IPv4 address. Also, this is also hierarchical, but divided only two parts. The first part of the address called prefix define the network, and the next or second part of the address called suffix and define the host, okay. The prefix length is n bit and suffix length is very clear, 32 minus n bit. If network take n bit, then very clear, host will take how many bit? 32 minus n, because the overall length of that address is 32 bit. If first n bit take host ID, then the next 32 minus n will take host ID. Okay. So, first network ID and next host ID. So, the prefix length, a prefix can be fixed length or variable length. Okay. The network identifier in the IPv4 was first designed to fixed length prefix. This scheme, which is now obsolete, is referred to as classful addressing. Okay. So, when you have to understand the IPv4, the first you have to understand the classful addressing. What is the classful addressing? Okay. So, the structure is like this: overall 32 bit use for the logical addressing IPv4. So, this 32 bit for sender and 32 bit for receiver address. First n bit for prefix known as the host, network. Prefix indicate network ID and suffix indicate host ID. Okay, so it is clear. This IPv4 have the two part. First, we are talking about the classful addressing here. We are talking about the classful addressing. In classful addressing, there is a two part. First is the network ID of n bit, and the second 32 minus n bit for the host ID. Okay, that means first of all we have to reach a particular network by using the network identifier, network ID. Then we have to select a particular host in that network by using the host ID. That is the second part, prefix. Divided into 5 classes known as A, B, C, D and E. So, in classful addressing, the overall 32 bit address space is divided into 4 parts and 4 classes: class A, then class B, then class C, D and E. They are the 5 classes basically. So, in IPv4 classful addressing, the overall address space is divided into 5 subspaces: A, B, C, D and E. Okay. This is very important. This class A, then class B, class C, class D and class E. So, how we understand the particular IP address belong to which particular class? Okay. So, for class A, the IP address always start with 0 in binary form. Basically, this 32 bit representation have different representation, like binary representation, maybe dotted decimal representation, and then maybe hexadecimal representation. So, this 32 bit address may be represented into any these 3 form: binary, dotted decimal and hexadecimal. But most frequently this dotted decimal representation is preferred and used. What is dotted decimal notation? These 32 bit is divided into 4 byte basically. Okay. First byte 1, byte 2, similarly byte 3 and similarly byte 4. This is the byte 4. Okay. So, first byte, second byte, third byte, fourth byte. This is the 32 bit address. Okay. So, in dotted decimal notation, after first byte there is a dot, then after second byte there is a dot, After third byte, there is a dot. So there is a 3 dot that place between 2 byte, 2 consecutive byte. First byte, then second byte, and third byte, and fourth byte. So this first byte means 8-bit stream, na? So these 8-bit stream is represented in decimal number. Like suppose we have 1 1 1 1 1 1 1 1. All 8 as 1 1 1 1. Okay, is it visible? All 8 as 1. Suppose this first byte contain all 8 as 1. Similarly, suppose second byte contains all 0 0. All 0 0. It may be possible. All 0 0. Third byte contains suppose 1 0 0 and 0 0 0 0 0. Suppose this one third byte. This is byte 1. Suppose this is byte 2 and this is suppose byte 3. Similarly, suppose byte 4 has all 0 0. Okay. So in dotted decimal notation, first of all, there will be 8-bit division of all 32-bit. First 8-bit, second 8-bit, third 8-bit, and fourth 8-bit. Very clear? Then after first 8-bit, there is a dot. Second, after second, there is a dot. After third, there is a dot. Then what is the next step? Next step is this binary stream is converted into decimal. So suppose this byte 1 contain all 1. So we know that this give in decimal number all 8 1 give which number? 255. Am I right? 255. Simply you have to convert into decimal. Okay. Similarly, this byte 2 all 0 means this give in decimal number 0. This give 25. And suppose this 6 5 times 0, then 1 0 0. This is the byte third stream. So this give, we know that this give decimal equivalent to 4. Okay. And suppose last byte 4 also contain all 0. So now we can write all these combination binary number into dotted decimal notation. Like first one is the 255. Second byte, then dot, second byte is 0, then dot, third byte, what is third byte? 4, then dot, what is the last byte? Suppose all 8 0, so what will be 0? This is the dotted decimal notation of the IP address. How many bit? 32 bit. There are the 4 division, first byte, second byte, third byte, fourth byte, and dot is placed in consecutive, between consecutive byte. Okay. And if we are talking about the binary representation, so simply this is the binary like this one. Okay, all 8 1, then all 8 0, then all the 6 times 0, then 1 0 0, then last 8 0 0 0 0. This is the binary. Similarly, there is other notation hexadecimal. Hexadecimal, we know that 4 binary symbol is converted into hexadecimal equivalent number. So there are the 4, there are the 3 common notation that is used in IPv4: binary, dotted decimal, and hexadecimal. I think this is now clear. Okay. Now we come at the address. What is the meaning of all these addresses? Class A, class B, class C, class D, class E. So class A always, if we are talking here the binary representation. Okay, binary representation. Suppose 32-bit represented into binary number. So this class A always start with 0. So first octant, first byte, if always start with 0, then we come to know that that address belong to class A. Okay. Then what about the class B? If the first octant of the IP address, 32-bit, contain this stream, at the very beginning 1 0, that start with the 1 0, then we come to know that belong to the class B. What about class C? If the first byte, in first byte the first third bit is 110, that belong to class C. Similarly, if the first byte first 4 bit is 1110, then that belong to class D. Similarly, if the first 4 bit is 1111 in first byte, we come to know that belong to class E address. Okay. One important thing here we are assuming that our IP is in binary representation. Okay. So first bit 0 start, then in class B 10, then class C 110, class D 1110, class E all 41. Okay. Similarly, for decimal, suppose you have given the dotted decimal notation, and now we are asking that you have to identify the class of that particular IP address. Okay. So class A have always first byte between 0 to 127. Okay. So 0 to 127, if first byte, first this dot, first byte give the number, decimal number between 0 to 127, then that class, that address belong to class A. Similarly, if the first byte contain the decimal number between 128 and 191, including these numbers, class B address will be there. Okay. Similarly, if 192 to 223, class C, 224 to 239, class D, 242, 255, class E. So, by this way, we can identify. This is the one thing, how to identify a IPv4 in which class that belong. Now, we talk about the class A. In class A, only one byte, only the first byte is used for the network ID. First byte reserved for the network, and remaining 3 byte and 24 bit reserved for the host. That means, what does it mean? It means that in class A, there is total 2 to power 8 network may be designed. Okay. And in which each network has the capacity of 2 to power 24. These number of devices may be connected in each network. In class B, first 2 bytes reserved for the network ID, and the last 2 bytes reserved for the host ID. Okay. Yes. And in class C, first 3 byte reserved for network and last 1 byte for host. What it means? That means class C have the more number of networks, because this is network ID. That means how many network can be designed here? 2 to power 24. This 3 byte give 24 bit. 2 to power 24. These number of network may be designed using the class C. And what is the network size? Network size is less here, 2 to power 8. Only 1 byte is reserved for the host to identify the host. That means 2 to power 8 will be the size of each network. And how many network can be designed? 2 to power 24. In class D, that is the reserve, and class C for the multicast. Okay. Multicasting. So, this is a very important some example. You have to identify basically the class. This binary IPv4 is given. You have to find out in which class this belong. This is the binary address. You have to identify the class. This is the dotted decimal notation. You have to find out the class. This is the dotted decimal, you have to find out the class. So, similar to first, we are taking the first example A. Here in this binary representation, see, there is one thing always, when you have to identify the class of address, so you have to only focus on the first byte, okay, only on the first byte, either that is in binary or in decimal. If first byte start with 0, certainly you have to know that that is the class A. So, this is the class A. In previous slide, you can see that class A always start with 0 at the first byte. Similarly, there is a class, this is the 1, 1, 0 and this continuous binary stream. So, 1, 1, 0, this is the identification of class C. See here 1, 1, 0, that identify the class C. Similarly, in binary decimal notation, decimal, dotted decimal, 14 means class A, because class A always have 0 to 127 decimal number in first byte. Similarly, 252, this is a class, let come at the previous 252, where this lie here, 242, 255. So, this identify class E, am I right? This is class E and this is class A. Similarly, as we know that binary notation can be changed into decimal and decimal notation can be changed into binary, very easy. Simply this is the basically binary to decimal conversion and decimal to binary conversion, okay. Like change the following IPv4 address from binary to dotted decimal notation. This is the IPv4. So, first we have to divide into 4 byte, first byte, second byte, third byte and fourth byte. Here already they have given in divided form, first byte, second byte, third byte and fourth byte. So, what you have to do to change in dotted decimal? You have to put dot here, then here, then here, okay. And this binary stream is converted into decimal number. So, tell me what is the decimal equivalent of this 1, 6 times 0, then 1. Who can convert this into decimal? So, see, to convert in decimal, there is a very easy approach. We know that this binary number system is a weighted number system and each and every decimal is also weighted number system. Each and every position have its own weight. So, in binary, we know that the first have the weight 2 to power 0, then 2 to power 1, then 2 power 2, then fourth bit 2 power 3, fourth bit 2 power 4, fifth bit 2 power 5, sixth bit 2 power 6, then 2 to power 7, 1, 1, 2, 3, 4, 5, 6, 7, 8. This is the all 8 position, all 8 bit, which have these weight 2 to power 0, 2 power 1, 2 power 2. If we write in decimal, that means this is the weight, nothing but this is 1, 2, 4, 1, 2, 4, 8, just twice, 16, 32, 64. How many bits are there? First bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit, and then 128, the 8th bit. Okay, this is the bit position. When you are asked to change from binary to decimal, you do nothing but you have to adjust all these binary stream here. So, first is 1 here, first bit 1, then 6 0, 1, 2, 3, 4, 5, 6. The last bit is 1 here. See here, I am writing this number, the first byte 1, 6 times 0, 1. We have right here. Okay. Now, just add the weight corresponding these number. So, this 128 and this 1 is added. So, 128 plus 1, that will be 129. So, first byte give the 129. Similarly, if we convert this binary number with the same procedure, this will give 11. Similarly, when we convert this number 4 times 0, 1011, this will give again 11. And if we convert last byte into decimal, certainly this will give 239. So, what will be the dotted decimal notation? 129.11.11.234. Similarly, the other example is also there. So, you can easily convert by using this logic from binary to decimal, and vice versa is also possible. When you have to divide 129 into binary, you can easily convert. You have to divide 11 into binary, you can convert in 8-bit representation. 11 convert in binary in 8-bit representation. Similarly, 239 is converted into binary by using 8-bit representation. So, this is the interchange between binary representation to dotted decimal notation. Okay. So, this is the next is the subnetting part. We will discuss in next lecture. Thank you. Thank you very much.